Imagine you are keeping track of 50 club members in a spreadsheet. It starts simple, name, email, and phone numbers. But then, someone gets added twice. Someone else's email gets overwritten. Now you are trying to track payments, committees, and event RSVPs, and it's chaos. It's when you realize you will need a structure. You need a better way to organize, connect, and protect your data. This is where databases come in. But what exactly is a database? Why do we need to organize data into tables? And what makes something a primary key? Why do all modern apps, from social media to your banks, rely on something called RDBMS? In this video, we'll unpack the building blocks that make it all work. We will start by defining a set of fundamental concepts before giving you the first taste of SQL. We will start with a simple question. What are relational databases and tables? What is a relational database? A relational database is simply a collection of tables. What is a table then? A table is something like a spreadsheet with data. As you already know, data in a spreadsheet is organized into rows and columns. The same can be said for a table. However, a table is different from a spreadsheet with data, because a table is used to represent a single entity or a relationship between entities. So to fully understand what a table is, we need to understand what an entity is first. So what exactly is an entity? An entity is an object or concept that can be described by many attributes. Suppose that we are running an online store called the Sci-Fi Collective that sells the sci-fi products such as time machine that takes you back only 5 minutes in case you forget your keys. Products sold by the Sci-Fi Collective are entities, and each can be described by at least 4 attributes: name, description, price, and the manufacturer. When we map products to a table in the database supporting the online store of Sci-Fi Collective, the 4 attributes will be mapped to 4 individual columns, and each product will be represented as a row in this table, like what you see here on the screen. In addition to the 4 columns, you may notice that we added another column, Product ID, in this table. All values in the Product ID column are unique, and can be used to identify each individual row or each individual product. We call Product ID the primary key of the product table. Each table should only have a single primary key. We will discuss more about the primary key in the future videos. That said, a table is similar to a spreadsheet with data, but also bears important differences because a single table is supposed to represent a single entity or a single relationship between entities. If you try to squeeze more than one entities together into a single table, bad things can happen. For example, if we decided to store the information of customers and products in one table for the Sci-Fi Collective, for example, the table will look like this. This table is a typically poorly designed table. You can spot the data redundancy issues first, like this. Beyond that, such a design can cause many unexpected problems. For example, if a customer's information appears in only one of the rows, when you want to delete a product, you have to delete the customer in the same row from the database as well. This problem is known as the delete anomaly. For another example, from time to time, we need to insert into this table a product that no customers have bought. But the table requires us to provide valid customer information whenever we want to add a new row. The contradicting requirements leave us in an awkward situation. We can't add any new products at all. This problem is known as the insertion anomaly. In short, a table can only represent a single entity or a relationship between entities. Now you have come to know quite a few important concepts. Let's move to the next one, the Relational Database Management System, short for RDBMS. So what's an RDBMS? First, an RDBMS is a software. It is responsible for interacting with the underlying hardware and operating systems, so that it can take care of how to physically store and manage data in a relational database. You may be familiar with some commonly used RDBMS, such as MySQL or MariaDB, or SQL. When you need to deploy a database that you designed, you will need to interact with one of the available RDBMS on the market. So to link RDBMS back to the concepts of databases and tables, an RDBMS is used to manage and maintain different databases. A database organizes data into different tables. Another important purpose of an RDBMS is to provide tools and functions to manage databases. One of the most notable tools that nearly all database systems support is structured query language, short for SQL or SQL, a programming language that you can use to create, modify, or query data stored in tables. Although different database system vendors may implement their own variations and extensions, SQL has been standardized over years. As a result, the consistency of SQL among different database systems is very high, and its variations are small. In the context of database design, of course, SQL may seem less important. Database design doesn't necessarily require you to use SQL. Some database systems even come with graphical software and tools to generate SQL script that automatically create databases and tables based on your design. But having some understanding of SQL can make it easy for you to learn database design, especially when it's related to structural or design problems such as data integrity, optimization, and scalability. After all, SQL is a standardized language that most database systems use, so knowing SQL will allow you to rely less on the graphical tools and work with different types of database systems. Next, you will learn SQL by executing your first SQL query. We will use the example that you saw, the database of the Sci-Fi Collective. That database may contain many tables, but the product table is all you need to focus on for now. The product table looks like this. The goal of our first query is simple. We aim at getting the names of the products whose price is above $20 from the product table. The query says select name from product where price bigger than 20. Before we break the query down and get to its details, let's run this query in an actual database first.
You can find the GitHub repo that contains the data we showed to you in this video at this address. It's also linked in the description of this video. You can clone the GitHub repo to your local machine or download it by clicking the button of code here. Then there's a choice named download as a zip file. I already have the repo cloned locally on my machine, so I'm gonna open it in the VS Code environment. Everything you need is from the folder named Chapter 1. Here, in this folder, you can see a set of SQL scripts and a README file. Here. You can follow the instruction in the README file to install your preferred database system and run the prepared scripts accordingly on your local machine. However, here we will go with the easiest approach, which is to use a tool named SQLite Online. Essentially, SQLite Online is a database running on the cloud. Let's open that. As you can see, in the left sidebar, you can choose the target database system that you want to use. So you have 4 different options, including SQLite, MariaDB, Postgres, and MySQL. So we are going to go with this choice, SQLite. That means we need to firstly import and run the prepared SQL script from the Chapter 1 folder. In our case, that file will be SQLiteOnline.sql. So we are going to import this file. If you ever get confused, you can use the README as a reference. It basically lists everything you need to do to get things done. Okay, so this is the target file, SQLiteOnline.sql. So let's import that file. We are going to click this import button. After that, we are going to click open and try our best to find the file. In my case, that file is saved in this folder named Grokking Relational Database Design, then Chapter 1, then SQLite Online. So I'm gonna click open. After that, I'm gonna click the OK button. There would be some info popped up telling you that the script has run. So what does the script do? The script handles creating a database and a table, then populate it with the same data that you saw from the last few slides. Before we write our first SQL query, let's take a look at the table again in this interface. So we are going to run this provided SQL query, select a star, which means everything from the product table. And we are going to click run. As you can see, every row from the table has been presented here on the screen. Same as what you saw in the last slide. The 5 columns are product ID, name, description, price, and manufacturer. Product ID is the primary key. Note that all column names are lowercase. The same can be said for the table name. The 10 rows representing 10 different products. 5 of them are sold at a price below $20, and the other 5 are sold at a price above $20. After all these steps, you will be ready to query the product table. You can type the query into the code editor here on the SQL online interface. So that will be select name from product where price bigger than 20. After that, don't forget the semicolon. In the end, we are going to click run. As you can see, a single column of 5 rows, or say 5 product names, are returned. Congratulations on running your first SQL query. Just in case, if you have typos in the column name or table names, SQL will know and complain. For example, if we misspell the column name as names instead of name, if we click run, you are going to see some complaints from SQL. So be careful with the column names. Well, how does the query achieve our goal? The part where price bigger than 20 may be a dead giveaway of what it does. The query retrieves the names of products whose prices are higher than 20. That's why it returns only 5 of them, the 5 products that are sold at a price bigger than 20.
Now let's break down the query and try to digest every bit of it. You may notice that this SQL query has a lot of similarities to plain English. To be specific, SQL is like English, but it comes with little to no small talk. And you don't have the same freedom in word choices when it comes to putting together a SQL query. You must use a set of SQL clauses and follow some rules. In your first query, you used the following 3 clauses. The first is the select clause. The select clause allows you to specify the columns you want to retrieve from a table. In your first query, you only asked for the name column, thus the select statement, or say the select clause, was select name. Second, the from clause specifies the source you want to retrieve the data from. It can be 1 or more tables. In your first query, you asked only for data from a single product table. Thus, the from clause was from product. Third, the where clause allows you to specify the conditions to filter the data retrieved by the select clause. In your first query, you want only the names of those products whose prices are higher than $20. Thus, the query was select name from product where price bigger than 20. Last, you should always use a semicolon to indicate the end of a query. The semicolon essentially tells the database system that this is the end of a query, and anything that comes afterward will belong to a new query. Let's quickly review what we covered. You saw how messy a spreadsheet can get and why structure matters. You learned what a relational database is and how it organizes data into tables based on entities using primary keys. You also wrote your first very SQL query to retrieve data from a table. These are the essential building blocks of every modern database, and they're just the start. If you want to dive deeper into database design thinking, this series is based on the book Grokking Relational Database Design, which walks through these ideas step by step with real-world examples. The link is in the first comment. What was your biggest aha moment from this introduction? Or what still feels fuzzy? Please drop a comment. I would like to know where you're at. And if this helps to lay a solid foundation, Feel free to like the video or subscribe to follow the full series. In the next video, we'll walk through the core building blocks of SQL, so that you can start reading and writing SQL queries with confidence.